All right, guys, welcome to lesson 7.2. We're going to be talking about adding and subtracting rational expressions today. We're going to look at three different scenarios. Sometimes you get really lucky and you have a situation where the two expressions already have a common denominator. That's one of the nicest opportunities to add and subtract you'll find. But we'll look at also how to deal with uncommon denominators. And once again, like last time, we'll kind of make a difference between whether you're dealing with monomials or polynomials. We'll look at some problems that are just monomials, then we'll look at problems that are polynomials. Okay, so common denominators and uncommon denominators with monomials and polynomials, and that's pretty much going to be the gist of it. Let's jump in and see what it looks like. So the first one we're going to look at is common denominators. So they already have a common denominator. So that's going to be the first type of problems that we're looking at today. So as you guys can see, I'm adding together these two rational expressions. And these two rational expressions already have a common denominator of 6m squared plus 30m. So how do we do this? Well, let's review basic fractions first. So you don't need to write this, just watch for a second. If I told you I have 2/5 and I want to add to that, how about 8/5? How would we do it? Well, the first thing you would do is you would add the numerators, right? That's going to be 10/5. And then afterwards we would reduce, right? And we're going to follow a very similar process here. We're going to add the numerators and we're going to put them over that common denominator. And then after that we're going to reduce if we need to. Okay? So let's start by adding these things together. So I have m minus 6 being added to m minus 6 all over the common denominator. So matter of fact, instead of saying adding, I think I'll go ahead and I'll just put combine. You'll see why I choose that word later. But basically, we're just going to combine the numerators first. So we have m minus 6 plus m minus 6. So if you combine your like terms here, m plus m is going to give me 2m, and minus 6 and minus 6 makes minus 12. And now I think I want to go ahead and just extend this arrow a little bit because it actually goes all the way over here. So combine the numerators is step one. So that's the first thing. The next thing is you're going to want to factor if possible, because sometimes factoring and canceling factoring will allow you to cancel something out. So what can I factor out of the numerator here? I can factor out a 2. What can I factor out of the denominator? I could factor out a 6m. Now, as you can see, the next thing you do is you're going to factor. So I'll label my steps as A and B here. So combine the numerators and factor. And then finally, can you cancel? And in this case, I can't cancel anything out. So, no, nothing's going to, oh, actually, we can. I see a little bit of reducing that we can do. The 2 and the 3, the 2 and the 6, we can reduce those. So let's do that. 2 over 6 reduces to 1 over 3, right? And we don't really need the 1 in the front, so we'll leave it like that. So it's a three-step process so far. Combine the numerators, factor, and then cancel or reduce. Okay? So that's adding. We'll do another example, though, before I set you guys loose on one. Let's do an example that involves subtraction. Now, you'll notice that they still have a common denominator. So the first step is still going to be the same. We're going to combine the numerators together. something different will happen this time when combining the numerators. The difference here is going to be the fact that we need to distribute the negative. That didn't happen last time because it was a positive. So in this case, we have x plus 1. And by distributing the negative, it's going to, matter of fact, at this point, we don't really need parentheses anymore. It's going to make minus 4x plus 6. And then by simplifying all that together, we have x minus 4x is negative 3x. 1 and 6 makes 7. And on the bottom, we have this. Okay, so we have now successfully combined the numerators. And so the purpose of me including this extra example that involves subtraction was just so you guys can see what I have written in red there. Whenever you're subtracting, you're going to be distributing that minus sign into the second numerator. Okay, and then you combine your like terms. All right, the next step is to factor. Now the top does not factor. There's no GCF there. But the bottom I can take out a 6. And as you guys can see here, nothing's going to cancel or reduce. And it's actually not too uncommon to not be able to do this last step. That's why I kind of assumed we wouldn't be able to do it last time, because it doesn't happen often. But in this case, there is nothing we can do there. You can't cancel or reduce, so we're done. Now some of you guys might be thinking, well, wait a minute, Mr. Bailey, can't we reduce the 3 and the 6? And the answer is no, because this 3 is connected with the x, which is being added to the 7. And as we said before, if you ever have this situation, you can't take the a away from that a because it's being added to something else. So that 3, since it's combined with the x, which is being added to 7, they're inseparable. So you can't do that. Okay? All right, so we'll go ahead and let you guys try one of these. All right, guys, so here's 2 for you. Go ahead and pause the video and see how you do. All right, so there are the answers. Let you guys go ahead and study that a little bit. A couple little notes that I'd point out here is that the 6 and the 2 reduced to make 1/3, right? But you don't need the 1. And then over here, these canceled out, leaving me with what I have. But some of you guys might notice, well, you can factor this still. And for now, don't worry about that. But we will talk about that a little bit later today. But in this case, it wouldn't have mattered if you factored it or not. So you could have, and you would have been fine. But that's as simple as that one gets. All right, let's move on to the next set. So as I mentioned to you guys earlier, today we're going to look at 3 different situations. The first situation is how to deal with common denominators, which is what we just finished doing. But now we're going to look at the 2 types of problems where you're going to have an uncommon denominator. And, well, whenever you're dealing with monomials, I just want to treat those separately. Let's go ahead and see what that looks like. So right now I have 2 rational expressions. They're both consisting of nothing but monomials. Well, let's go ahead and title this first. These are monomials with uncommon denominators. In other words, the denominators don't match. Okay, well, let's see. How are we going to do this? Well, we're going to get those denominators to match by multiplication. Okay, so how are we going to do this? Basically, what we need to do is we need to ask ourselves, what does this side need to look more like this side? Well, in order to get these to match, this side already has an x, so they already have that in common. That's nice. We're going to leave that alone. But the problem is that the side on the right over here has a 5 in the denominator, but the one on the left only has a 3, right? So how are we going to fix that? Well, what we're going to do is we're going to multiply whatever it doesn't have. So, for instance, Let me rewrite it really quick here. The left denominator doesn't have a 5, so I'm going to multiply it by a 5. Okay? Is it missing anything else? No. Now the left side is complete. It has a 5 and an x, just like this side does. But we don't want to just focus only on one side. We want to focus on both sides. So now I want to find out, what does this side need to look like this side? So what does the right side need? Well, it doesn't have a 3, right? So I need a 3 down there. And it also doesn't have a y squared. So I need to multiply a y squared down there. So that's the idea. Whatever they're missing, we need to multiply it to make them match. Okay? Now, but we got to remember, you're only allowed to do that if whatever you do to the bottom, you do to the top. So on the left fraction there, since I multiplied a 5 on the bottom, you also need to multiply a 5 on the top. And on the right-sided fraction, since I multiplied the bottom by 3y squared, I need to multiply the top by 3y squared. And now we're going to go ahead and put those together. So the first step, though, is to match the denominators. Multiply to match. So find out whatever they need and multiply it on both sides. Okay? I'll put denominators here to be specific. Okay, so now the next thing we can do is simplify. So multiply these things together. 5 times 2 times y. Well, that's going to be 10y. Next one. 5 times 3 times x times y squared. That's going to be 15xy squared. Same thing on the other one. Multiply these together now. So we have 15y squared, and on the bottom we have 15xy squared. And at this point, they should have a common denominator. So we're going to simplify by multiplying the numerator and denominator. Okay? So first of all, we multiply to match, and after that we go ahead and do that multiplication to simplify it. All right, well, now that they have a common denominator, we can combine the numerators. So now that we've made a common denominator, we can do the same steps that we did on the last set of problems. So now that they have a common denominator, we can go ahead and combine the numerators together. So 10y minus 15y squared all over the common denominator here of 15xy squared. Okay? What do we do after we combine the numerators? We factor. Now for the top, there is a GCF, right? We can take out a 5 and a y. The bottom is a monomial, so we'll just leave that one as is. And now we're going to reduce or cancel. So if it's a monomial, we're just going to reduce it. If it's a polynomial, we'll cancel. But in this case, we can reduce. So we have 5 over 15 is 1/3. And then we have y to the first power, which can be combined with y to the second power on the bottom, right? How do we do that? You subtract the powers. So 2 minus 1 is 1. And since the bigger one was on the bottom, it's going to be y to the first power on the bottom. The x is going to stay exactly the way it is because there's nothing to cancel it with on the top. And then we also still have the 2 minus 3y hanging out there. That didn't change. Okay, so we reduced or canceled next. Reduce and cancel. All right, and then from there, I would just make it look pretty. We don't need the 1 in the front, so we can just put that. And we also don't need the 1 on the power, so we can write that. So that would be the way to write your answer right there. All right, so what did we do? Step 1, we multiplied to match the denominators. Step 2, we went ahead and simplified them by multiplying everything out. Then the steps were the exact same as they were before. Combine the numerators, factor, and reduce. Okay, so let's have you guys try one of those. Go ahead and pause the video here and see how you do. All right, so there's your final answer there. In the green and purple, I multiplied to match. The left fraction needed an m because the fraction on the right has an m in the denominator. And then the fraction on the right side needed an n squared because the fraction on the left had an n squared in the denominator. And then step 2, after you multiply to match, you simplify. So m times 2m is 2m squared, and 3n times n squared is 3n cubed. And then I just put these together, and now as you guys can see, we've got two fractions with a common denominator. And after you get that, you pretty much just follow the same steps that we did for the last problem set that we worked on, which is to combine the numerators. So that's what I have here. And at that point, there's nothing else to do because you can't factor. And if you can't factor, you can't cancel either. So we're done. That's the end of that problem. All right. So moving on to the next step. So we've talked about dealing with polynomials, how to add and subtract them when they have a common denominator. And then we've done our first one, monomial rational expressions with an uncommon denominator. We're going to move into our final discussion, which is how to deal with rational expressions that have polynomials with an uncommon denominator. And at this point, I'm just going to go ahead and write you guys out a list of steps. Now, technically, these steps would work on every single problem that we've done so far. Okay, it's just that you don't need a lot of these steps for the other problems we did, so I just kind of did them separately, and they were a little bit easier. I wanted to ease you guys into it. But this is the big picture view here of everything that you'll need to do to ever combine any rational expression. So the first thing is going to be to factor your denominators. And after that, you can multiply to match, simplify, combine, factor, and cancel. So steps 2 through 6 we've done already today. But step 1 is the new one, which is the granddaddy of them all. So I'm just going to do a bunch of examples at this point, and then I'll let you guys do a bunch of examples. And we'll go over those examples and see how you guys did. And then after that, we'll be done with our lesson for the day. So let's go ahead and take a look at them here. All right, so step 1, factor the denominators. Well, I can't really factor a 3, so that one's done. We can't do anything there. But I can factor this, so let's do that. Step 1 is to factor the denominator only. In this case, that's all you can factor anyway, but I could take out a GCF there. So factor the denominator. So I found the one piece that I could factor, and I factored it. I took out a GCF. It could be a difference of squares. It could be a box method. In this case, it was just a GCF. All right. Step 2, the next step, is to multiply to match. So this side on the left needs a 3, so it matches the denominator on the right side. And this one on the right side needs two things. It needs a 2, and it also needs a v plus 5. So now both denominators have the same thing. They have a 3, a 2, and a v plus 5. But don't forget, whatever you do to the bottom, you have to do the top. So I have to multiply the top here by 3, and I have to multiply this top by 2v plus 5. Okay, so that's step 2. Step 1, factor the denominator. Step 2, multiply to match. Step 3, we're going to simplify this now by multiplying everything that we have in these numerators and denominators. So for instance here, that's going to be 15v. The bottom, I'm going to say for the bottoms, only multiply the monomials together, but don't do anything else. So for instance, 3 times 2 is 6. I'm just going to leave it like that. I'm not going to distribute the 6 in. All right, there's a reason for that. For now, let's go ahead and do this one. Now for this one, this is 4v, right? 2v times 2. And then I'm going to multiply that in. Remember, I'm not going to distribute on the bottom, but on the top I will. So 4v times v plus 5 is going to be 4v squared plus 20v. And on the bottom, we're going to have 6 times v plus 5. So once again, I mean, you could multiply in on the denominators, but it'll actually just end up making a little bit more work for you if you do. All right, so let's review. Step 1, factor the denominator. Step 2, multiply to match. That's what I have in green and purple there. Step 3, simplify the numerators and denominators, but don't do any kind of fancy multiplication in the bottom. Leave those kind of a little bit more factored. All right, step 4 is to combine the numerators, right? So I'm going to put these together. The 15v can be combined with the 20v, right? I guess I'll go ahead and write it out like I have been, though. I don't want to get too fancy just yet. So in this case, the 15v can be combined with the 20v to make 35v. Okay, the next step is to factor. So let's review. Step 1, factor the denominator only. Step 2, multiply to match. Step 3, simplify that. Step 4, combine the numerators. Step 5, we're going to factor now. Now this is why I didn't want to distribute on the bottom, because we have to factor anyway. So if I were to have back here, if I were to have multiplied that in there, well, when I get to this step, I'm just going to take that 6 back out. So there's no point in doing that. On the top, you have to do that, though. So you guys may recall that on the top, I went ahead and I did distribute this 4v in. And that's because if I didn't do that, I wouldn't be able to combine these together. So now we have this. Now we're going to move on to our last 2 steps, which is to factor and cancel. So the bottom doesn't need to be factored anymore, but the top does. So I could take out a v, which isn't really very much at all, actually. And on the bottom we have this. Well, my monomials are v and 6. Those don't reduce. And my binomials are these. Those don't reduce. So I can't do any kind of canceling. So we could stop there. My guess is that if you guys were to look at my multiple choice test, they would probably stop here since nothing cancels out. I don't think they would write it like this. So their thinking is, well, I'm not going to factor something out if it's not going to cancel. So they would just stop here. Okay. But you still want to factor out if you can to see if you can cancel some stuff out. So there's our steps. Let's take a look at another one. We're going to do a couple of examples just to get you guys used to it. Here we go. All right. For this one. So step 1 is to factor the denominators. Now look at my denominators. There's no GCF here, and it's not a difference of squares, so I can't factor that. There's no GCF here, and that's not a difference of squares, so I can't factor that out. All right, so there's no factoring. We can skip step 1. The next step is multiply to match. So the left side doesn't have a 2r minus 5. So I'm going to put a 2r minus 5 here and here. The right side doesn't have a 5r plus 3. All right, so now what do we do? Well, now we're going to simplify these expressions. So this first one's pretty, the one over here on the top right, that's kind of easy. So we're just going to distribute. That's pretty straightforward. That's going to be 10r plus 6 over. And as I said, don't multiply the bottoms out. If you have any monomials, you could put those together. But for binomials and stuff like that, we're just going to leave it. Just like that. All right. But now we're coming across something else a little bit unexpected here. This. How do we do that? Well, hopefully that should look a little familiar to you guys. That's a box multiplication problem. So let's do that. We have 2r minus 5 being multiplied with r plus 4. So we have 2r squared we have 8r that we can combine with negative 5r to make 3r. And then we have negative 20. So yes, you will have to do some box multiplication sometimes. All right, so step 1, factor the denominators. We didn't need to. Step 2, multiply to match. Step 3, simplify the numerators. And let's go ahead and move on to step 4. Step 4 is to combine the numerators together. All right. And since we're subtracting, to combine my numerators, I'm going to need to distribute this negative, which is another little thing we talked about earlier today. So that gives me 2r squared plus 3r minus 20 minus 10r minus 6. All right, let's combine our like terms. The 2r squared doesn't combine with anything. The 3r can be combined with the negative 10r to make negative 7r. And then the negative 20 can be combined with the negative 6 to make negative 26. Now, there's that. Now, the last two steps are to factor and cancel. Now, at this point, I'm going to go back to our steps. I want to make a few adjustments to our steps after going through a few of these. So what we talked about is whenever you're simplifying, we only simplify the numerators, not the denominators. So let's ignore that. But these last two steps, you only if necessary. Now, what do I mean by that? It's a lot of work to do these problems, right, you guys? So on a test, you're going to have multiple choice. And so my point is that after you finish step 4, which is what I just got to, just stop and look at your multiple choice options. If you see this there, then you're done. Okay. The reason why I tell you to stop here is because very often, after you guys get to step 4, you're not going to be able to factor it anyway. And if you're not able to factor it, you can't reduce it. So don't worry about it. This one's probably done. But just so you guys know, I mean, technically what you should do at this point is you should factor and cancel. Now, you guys don't need to write this, but you can watch me do it really quick. The bottom's already factored. But I'm going to try to factor the numerator here really quick. All right, well, this isn't going to work. I can already tell this because I would get 26 here and 2 here. 2 and 26 can't make negative 7. So I'm going to back up and let's try again. How about if I put the 13 right here and the 2 here? That's going to be 4 and 13. Well, 4 and 13 don't make 7 either. So it's not going to work. And I'm just being a little bit ghetto in how I'm going about it so fast. But my point is that I already know that most of the time, after step 4, it's not going to be factorable anyway in the top. So stop and just see if it's a multiple choice test and see if your answer is there. But in this case, the top doesn't factor, so I can't cancel. So I am, in fact, done. So a lot of times you won't have to do those last 2 steps. Let's take a look at one more. Oh, that's a note to myself. Make up one more that requires a box or a different squares. I can do it. Here we go. So let's say that I have 3 over x squared minus 4 plus x squared minus 4x plus 4 and guess we don't really need parentheses yet. All right, so there's that. So let's go through our steps. So why don't if I were you, I would encourage you guys at this point to go ahead and let's treat this like a guided practice. So at this point, I would encourage you guys to just do each step with me one at a time. So the first thing I want you guys to do is I want you to pause the video and do the first step. And when you unpause the video, you will see the answer. So this is what you guys should have gotten after the first step. The first step is to factor the denominators. Now on the bottom left, we have a difference of squares. X squared minus 4 becomes x plus 2 times x minus 2. The bottom the denominator on the right side is a box problem, and if you did the box correctly on that, you would have gotten x minus 2 times x minus 2. All right, go ahead and pause the video here and see if you guys can figure out what the next step is and do that. Step 2 is multiply to match. Now, the fraction on the left needed one more x minus 2 because the fraction on the right had two x minus 2's in the denominator, right? So the one on the left side also needs two x minus 2's. And whatever you do to the bottom, you do the top. So I multiplied the top and the bottom by x minus 2 on the left side. On the right side, it didn't have an x plus 2 factor. So I'm going to multiply the right fraction by x plus 2 on the top and bottom. All right. Now, step 3 is we're going to simplify the numerators. You're not going to do anything with the denominators, so the denominators are still going to look like this. And since there's two x minus 2's, I'm just going to put x minus 2 squared. I don't know if my software will do that, but it doesn't really matter. It's the same thing. But what I want you guys to do now is I want you to figure out what goes in these two parentheses here. So you need to multiply this and you need to multiply these. So go ahead and pause the video and see if you guys can figure out what goes in those two sets there. When you unpause it, you'll see the solution. Okay, so now we have our result here. So this one you're just going to distribute, right? And you get this. For this one, you need to do box multiplication. So you would have to do this whole deal here. And if you do your box multiplication correctly, you would end up what I have in parentheses down there, which is x squared plus 3x plus 2. All right, go ahead and pause the video here and do step 4. All right, and so here's the result of that. Step 4 is to combine the numerators and simplify that. So putting those two numerators together, the two 3x's come together to make 6x, and the negative 6 and the positive 2 come together to make negative 4. So my numerator now is x squared plus 6x minus 4. All right, the last step is to factor and cancel. Now, the bottom is already factored, so all you would have to worry about factoring is the numerator. But like I said, a lot of times at this point, it's not even going to be able to be done. So I'll save you guys the trouble. This cannot be factored, and so we are done. All right, and so that's the end of our lesson there for the day. That's adding and subtracting, but it's not the end of my lesson. I shouldn't have said that. It's actually the end of my examples. I want you guys to practice a little bit more here. So I'm going to put up 3 examples for you guys to mess around with and see how you do with them. So, all right, guys, so here's 3 problems for you. You don't have to do all of them. If I were to put these things in order of hardest to easiest, I'd say number 4 is the easiest, number 6 is the hardest. And so, if you want to do all of them, that's great. I'm going to give you guys a minute here to pause the video so you can check your answers. But if you only want to do 1 or 2, that's fine. And you guys are going to get a lot of practice on your homework anyway. But here you'll actually get to see how to work them out if you didn't get it. So go ahead and pause the video and give it a try and see what you guys can do. All right, guys, so I've gotten the steps written up there, and the answers are in boxes for each one of them. For each problem, A is the first step of factoring the denominator. For number 5, I didn't include that because you can't factor the denominator on number 5. Part B is where you multiply to match so that you get a common denominator. Part C is multiplying in the numerator. And part D is combining the numerators together. And none of them had steps E or F, which is factoring the numerator and canceling, because none of them could. So they're all done at this point. So hopefully that was helpful to you guys, and we'll see you guys in class.